Good morning. So, can't believe after 1 year, I had not done this paper. So, give students this paper to do. Thought I had the solution. And actually found that I don't have it. I don't know how come. I feel like I did it, but I think somewhere I just can't find it right now. But give them the paper to do, and I need to give them the solution tomorrow. So, let's go. It's 2 a.m. in the morning, 2:30. And I have to just get this done as quickly as possible. All right, so this is the in the 23 June, May 2023 AdMats paper 2. All right, so let's do this. This is the first question. I'm gonna try and do this thing one video per question. All right, so number 1. This is a full paper. All right, number 1 right here. So let me close this out. So first part tells us to solve this equation, giving our answer to 3 decimal places. So these are this guy's quadratic equation, and the matter of breaking this up can be expressed as a quadratic 3 to the x squares and so on. So the first thing is to pull up this power. This expression here is the same as 3 to the 2x times 3 to the 1. I can move this and put it in front. So it becomes 3 to the 2x. And then this power, I can break that up and put it as 3 to the x squared. So this becomes 3 to the x squared. All right, move this bracket squared. That's what this first term becomes. Minus 5 times 3 to the x minus 2 equals 0. That becomes a quadratic in x. So this is like 3y squared minus 5y minus 2 equals 0. But I'm not going to do that. I'm going to work with my 3 to the 2x, 3 to the x. I just want to factorize this now. So factors of this will be 3 times 3 to the x and 3 to the x. Factors of this 2 going here and there. And it has to be such that my far product and my near product gives me that middle term. So I need to put this 2 with the 3 to get my 6x. I'm putting a factor here, 2, 1 here. Signs are the same. Give the greater product the minus sign. The far product is 6, near product is 1. Far product is greater. Make it minus, near product plus. Check it. Far product is 6. Near product is 1. 6 minus 1 is 5. Those factors are correct. And so it's this equal to 0, which means that this is my subject. Make this my subject. 3 to the x would be negative 1 over 3. Or if this equal to 0, then 3 to the x is equal to 2. A positive number raised to a power cannot be negative. So this has no solution. That can be proven because if you want to get x out of the power, we will be taking the log of both sides. Log of this side, log of this side. You cannot find the log of a negative number. So whichever way you look at this is not valid. And so we are left only to solve this side. To get this x out of the power, we take the log of both sides. I'm going to log this side. Let's shift this over a bit. And I'm going to log the right side. This x comes to the front. So I get x log of 3 equals the log of 2. Out of space a bit. Let's make this a little bit smaller inside here. Right here. Make it a little smaller. So let's create a little bit more space for this solution. So back here, x is going to be the log of 2 divided by the log of 3. Divide the log of 3 on here, the x becomes equal to the log of 2 divided by the log of 3. And the question to give the answer to 3 decimal places. So let's go get the calculator. Where are you, calculator? Where are you? There. So I'm working the log of 2 divided by the log of 3. So log of 2 is a fraction. The log of 2 divided by the log of 3. 3 decimal places is 0.631. 0.631. 0.631. That's my answer right there. All right, next question. It says, this is a factor of that expression. Let's call this expression f of x, so we can reference it. F of x. And this is a factor. If that is a factor, it means then that this other factor can be written in the form 3 into x plus 2/3. 3 into x minus negative 2/3. And so this is my a. Remember, factor theorem says if k into x minus a, if k into x, and it's too thick, x minus a is a factor of f of x, then f of a is equal to 0. This is my a, negative 2/3. So I've taken this factor and written it in this form so I can identify my a. And so f of negative 2/3 is equal to 0. That's what I'm solving. So let's put that here. So f of negative 2/3 is equal to 0. That's what I'm going to solve. All right. So this is my a. So from this factor, f of negative 2a is equal to 0. So let's write that. F of negative 2/3 is equal to 0. So the matter of substituting negative 2/3 in that function and equate it to 0 and solve for the unknown b. Okay, so it's 3 times negative 2/3 cubed. Let me try to do it too thick. All right, let's do this again. All right, so it's 3 times negative 2/3 cubed plus b times negative 2/3 squared minus 3 times negative 2/3 minus 2. This is equal to 0. All right, what is this expression? I'm just going to put them in the calculator now. But this would be a negative, firstly. It will become a negative 8. Should be at 27 when I cube it. 3 into 27 was 9 times. 9 times 8 is 72. Negative 72. Let's check it. So it is 3 bracket fraction of negative 2/3 close bracket cubed. What did I say? What did I say? That becomes negative 8/9. Really? Really, just to show 3 times negative 8 Oh, okay. Over 27. This cancel is 9. Good. Negative 8 over 9. So this becomes negative 8 over 9 plus this becomes positive 4 over 9. So that's 4 over 9b. This becomes a positive 2. This becomes a positive 2 minus 2 equals 0. Solving for b. This is eliminated. So this transposes to that side. 4b over 9 equals 8 over 9. These cancel. b equals 2. If 4b is 8, b equals 2. Nice answer. Now that b is 2, what do they want us to do? So they want us to hence factorize this completely. So now b is 2. So with the b equals 2, and what is the factor again? Factor was 3x plus 2. So I have a 3x plus 2 factor. Means I can divide by that 3x plus 2. And remember, the b is 2. So I'm going to divide to factorize. So it's 3x plus 2 into this expression with the b equals 2. That becomes 3x cubed plus 2b, 2x squared, sorry, because the b is 2, minus 3x minus 2. I'm going to divide it to find my quadratic factor. This divided by this is x squared. X squared times this gives me 3x cubed and 2x squared. So these are also these are eliminated because I'm subtracting. This term and this term is the same. Those are eliminated. I'm left back with this minus 3x minus 2. This divided by this is negative 1. Negative 1 times these gives me negative 3x minus 2. And I am subtracting. This is 0. So my expression becomes this times this. So I can say, therefore, f of x is, and then I can factorize this here as a difference of 2 squares, where it is. This really here is x minus 1. So this factor is x minus 1 times x plus 1. That's what this quotient is. And so my f of x is the product of these 3 factors. So have been factorized completely. So my answer is f of x equals 3x plus 2 times x minus 1 times x plus 1. And this is my answer right here. Factorized completely. Nice. All right, next part. Determine the values of p for which this expression has 2 distinct roots. Now, this really should have been an equation equals 0, because it is a quadratic equation that has roots, right? I mean, this quadratic equation, if it has 2 distinct roots, then the discriminant b squared minus 4ac is greater than 0. B squared minus 4ac of this equation is greater than 0. And so I'm solving this. So what is my b? My b is the coefficient of x, which is 3. This becomes 3 squared minus 4 times a. What is my a? My a is the coefficient of x squared, which is p, times c. What is my c? My c is a constant term, which is 2p. This is greater than 0. This becomes a 9. So I now have 9 minus, this is 8p squared. 8p squared is greater than 0. That's a quadratic. All right. I can make my square term positive by multiplying through by a -1. I like to do my quadratics, my square term positive, but I have to remember to reverse the inequality sign. Reverse the greater than sign when I multiply by a -1. So the expression becomes 8p squared minus 9 is now less than 0. All right, let me make some space with this work. Shift this all over a bit. Shift this all. I'm trying to rush and I want to go and sleep. All right, so what are the solutions for this? Let's check if these values are correct, but I don't, I would like to get some perfect squares in this. But that's not a perfect square, so let me just double check this. So it's b squared minus 4ac, the b is 3 minus 4 times the a is p, and the c is 2p. 4 times 2 is 8, 2 times p is p squared. Okay, so I can solve this multiple ways. I know that my result is going to be between the roots produced by that. If I were to solve for the roots or the critical values, let's just do it here. Critical values related to this inequality will be such that 8p squared minus 9 is equal to 0. And so the p would be plus or minus. Transpose the 9, I would get 9 over 8 square root of 9 over 8. All right, that's what I would get, square root of 9 over 8, plus or minus. So if I have a sketchograph for this, it will be a smile. My horizontal axis will be P. My critical values, this will actually work out to 3 over root 8, but I can put the root of 9 over 8 just the same. So here will be the positive, and I'm putting an open circle because we're not including. So that will be the square root of 9 over 8. And here will be negative square root of 9 over 8. Negative square root of 9 over 8. And this inequality is referring to section below the x-axis, which then means that I want values between these two critical values, between them. And so my solution would be that my p is between these two critical values, less than the larger one, which is the square root of 9 over 8, greater than the negative square root of 9 over 8. Right? So these expressions could be simplified by putting 3 over root 8, and root 8 is 2 root 2, but still square root of 9 over 8. And that ends question 1. All right, so I'm going to pause and I will see you in question 2. Right, so see you in question 2, next video question.